to look at solving this system of equations using what is called minors. When we work with minors, what we're going to do is we're going to start with a 3x3 matrix and break it down into 2x2s. So I'm going to start with just the D matrix, which is just using the X, the Y, and the Z columns. And so I'm going to put in the -4. Again, we're only using the coefficients. So I have the coefficients of the X. Then I'm going to use the coefficients of my Y. Then I will use the coefficients of my Z. When I look at the minors, what I'm going to do is I'm going to select the first row. And I'm going to write those values down, leaving some space. And then what I have to remember is I want to remember that I'm going to add, subtract, and add. Or if you need to, think of same, opposite, same. Okay? Meaning I want the same sign as what it started with. So in other words, that -4 stays the same. I want the opposite sign of what this started with. And I want the same sign as what this started with. Okay? So I'm always going to change this middle sign from what it started with. So if this had been a -9, I would have changed it to a +9. The middle term always changes. Then what I do is I'm going to create 2x2 matrices for each one of these. When I create those 2x2 matrices, I'm going to look at the numbers sitting out front. And I am going to look at the 4 here, and I'm going to mark out its column and its row. And I'm going to look at what numbers are left. I put the leftover numbers inside this matrix, and that is what gets created as my minor matrix. This is my minor matrix. I have crossed out the column and row for this particular number. Then I will move to the 9. I will cross out its column and row, and I will put the leftovers, the 9, the 5, the 4, and the 6, in to create its minor. Then I move to the -2, cross out its column and its row, and put in the leftovers there. 9, 5, -5, and 1. And so what we've done is we have created the minors. So to actually get the determinant for this 3x3 matrix, we're going to have the -4 times, and then we're going to solve this 2x2 matrix. Remember, we take -5 times 6, which would give me a -30, minus the 4 times the 1, which would be 4. Then I'm going to have a -9, 9 times 6, which would be 54, minus a 4 times 5, which is 20. A plus and a minus right here would become a -2. 9 times 1 would be 9. -5 times 5 would be a -25, but I always want to put a subtraction sign in the middle. So I want to do 9 minus a -25, which this actually becomes plus a positive. So I have negative 4 times negative 30 minus 4 gives me a negative 34. Minus 9, 54 minus 20 gives me 34. Minus 2 times 9 plus 25 would give me 34. Now I do multiplication. Negative 4 times a negative 34 would give me a positive 136. Negative 9 times positive 34 would give me a negative 306. Negative 2 times 34 would give me a negative 68. I would subtract these together, and I would get a negative 238. This is my D matrix. This is the determinant of that D matrix. I would need to find now the dx matrix, the dy matrix, and the dz matrix. The dx matrix, I replace the x column with the results. When I talk about the results, that is whatever is in the equals column. So I will replace the x column with 12, 4, and 3. The other columns, my y and z columns, will stay the same. 9, negative 5, 1, negative 2, 4, and 6. And then I would find the determinant of this. For the dy, my x and my z columns would go back to normal. Negative 4, 9, 5. My last column, negative 2, 4, and 6. My middle column, my y column here, would change to my results. 12, 4, and 3. My dz determinant, my x and my y columns would be their original columns. So negative 4, 9, 5, 9, negative 5, and 1. My z column would be now the results column, 12, 4, and 3. Once you find these values, which in this particular case, you should get dx to be a negative 554, dy to be a negative 470, and dz to be a positive 421. Once you find these items, what you're going to do is you're going to do Kramer's rule to find x, y, and z. X is going to be dx divided by d. So you're going to take negative 554 and you're going to divide it by what you found on the original d, which was a negative 238. And you will simplify this. You can do this in your calculator. Don't change it to a decimal. So this simplified will actually become 277 over 119. You'll do the same thing with the y, except you'll use dy divided by d, and that's a negative 470 divided by a negative 238. And that can be simplified into 235 divided by 119. And z is dz divided by d, which will be 421 divided by a negative 238. And that can't be simplified, so that's just going to be a negative 421 over 238. And your final answer is always written in, if you just have two variables, x, y, ordered pair, this is going to be an ordered triplet, x, y, z. So you're going to have 277 over 119, 235 over 119, and a negative 421 over 238. So this method of solving determinants is called using the minors. So you're finding determinants using smaller 2x2s. So you can try using minors, or the other video that I've created has using the diagonals. It is totally up to you. Let me know if you have any questions.